Welcome once again to Minds Between Languages. It is our pleasure to bring to you today this interview with Dr. Michael Carl, who will be talking about the differences, similarities, and interplays between human translation and machine translation. Hi, Michael. It's very, very nice to have you here. Thanks for joining Minds Between Languages.
Yeah, thank you for inviting me.
We're going to be talking about machine translation vis-a-vis human translation and discussing some of the cognitive considerations that pertain to these two domains and their intersection. So why don't we get started by discussing a little bit machines proper? And I guess a fair initial question would be, what is machine translation? And what are the main research questions that revolve around this notion?
Okay, yeah, thanks again for inviting me to this interview. I'm happy to be on this Track series. Machine translation, it's a technology in which computers are used to translate natural languages, for instance, French into English or vice versa. And this technology has been around since many years, since the 50s. One of the first applications in computer science or in computers since the computers existed. And there have been a lot of different technologies that have been tried to do this translation. The question is always, how can a machine simulate human translation quality so that the translations become similar to what humans do? And of course, with these different technologies, rule-based, statistical, neuro-machine translation, all the fine-grained questions are quite different.
It's interesting that it seems to be that the goal, or one of the goals, is for machines to approximate what humans do. So would it be fair to say that humans are the gold standard for translation?
That has been considered like this, yeah. So there are various measures that quantify the quality of translations, and often these measures are with reference translations. So they look at how humans translate, and then they compare with this how machines translate. Yeah, so the reference is human translation. But interestingly, recently, one can see there are perhaps systematic differences between machine translation and human translation. And recently, the question evolved whether this should still be really the standard, whether we could have also a translation niche, so a special dialect for machine translations, and one just should just accept it, that there are slight differences as compared to humans.
That is very interesting. Another thing that I find, again, interesting is your own history in this field. How did you personally, Michael, become involved in this field?
Yeah, so I started studying in '85 communication in Berlin at the Technological University, and then in '87, and I was interested in linguistics and in computer science, something like this. And then in '87, I went to Paris, and there was something called computational linguistics, linguistique informatique, in Paris 7, that was the name of that university. And I inscribed to linguistique informatique. And at that time, they had a European project, Eurotra. There were French partners of this Eurotra project, and Eurotra tried to translate all the 8 or 9 existing languages in Europe at that time. So they had developed a huge consortium in every country, and they had a framework, a rule-based machine translation system called Eurotra, and that was taught in these classes. And we learned these different strata in this rule-based machine translation system. We wrote rules and dictionary entries and so on. So that's what we learned in the studies. And then later I got a job in Germany, in Saarbrücken, in the same project, so same Eurotra, but the German partner that was in Saarbrücken at the Institute for Informationswissenschaften, IAI. And I continued there for some time on Eurotra and on similar kinds of projects, but then became more interested in data-driven machine translation, which uses reference text as a background.
You are mentioning so here data-driven machine translation, which implies that there are other types of machine translation, which leads me to the next question, which is, what would you say are the main trends or school in machine translation research?
Yeah, so when I got involved in machine translation, it was this rule-based. It was quite sophisticated formalism, very advanced technology and so on. So we were working with rule-based machine translation. And this was the dominant technology, I would say, until the beginning of the 90s. But then increasingly parallel text means translations became electronically available, and technologies instead to extract this knowledge from these texts, from these translations, became more popular, more available, computer power increased and so on. And soon it turned out that statistical machine translation was produced much better quality than rule-based machine translation. So we have a rule-based machine translation where linguists sit there and write dictionary entries and rules how these dictionary entries could be combined. And then we have a statistical machine translation where algorithms look into bilingual text to extract the knowledge, these kinds of word translations and combination rules and so on. And more recently, we have a neuro-MT where whole sentences are piped into the system instead of chopping up the sentences into parts, and the whole sentences are given and they are mapped into a complex kind of mapping network, and translations are produced in this way.
It's interesting that there's like this back and forth in terminology between notions that are primarily rooted in machine translation, and then they become used to think about human translation, and also the other way around. Now you're talking about this neuro approach, which in a way is inspired by actual biological structures that exist within the human organism. And in general, in the history of cognitive science, computer metaphors have been very prominent in our thinking, in our rationalization, our conceptualization of how the human mind might work. I would like to ask you, Michael, in which way or to what extent are machine translation notions a good or a bad metaphor to understand how actual human beings go about the translating task?
Yeah, so metaphors are, of course, they work or they don't work, they have some value. But here we're talking about a computational theory of mind, which is not a metaphor, but which is a theory. And this was, I think, a theory, or is still a theory, that says we have representations and rules, and whether those representations and rules are implemented in a machine or in the mind doesn't work. The function is the same. So whenever we implement something in the machine, then it's a simulation of the mind work. So I can give an example. When we worked on this machine translation system, Eurotra, we had this impression. We would implement a small kind of a rule, and then we would be happy and were thinking, oh, we captured something, how the mind probably works. For instance, in English, you would say, I'm on the bus. So the bus is conceptualized as a surface where you are on the bus. And in Germany, you're saying you're in the bus. So it's like a container. Okay, and then in Eurotra, we would annotate this information in the dictionary. We would assign a tag with bus. In English, it would be surface. In German, it would be container. And then we have all these complicated rules to analyze the source sentence, to transfer this into the target language, to regenerate the target language. And if it worked, then it on the bus would be translated into in the bus in German. And we would think, oh, we understood a little bit how the mind conceptualizes language and so on. And of course, there was an idea there's a finite amount of those kinds of concepts, and we could capture this eventually all with rules and with dictionary entries and so on. So I think this goes into the direction of computational theory of the mind, yeah, where we have representations and rules. And I think not many people really believe in this anymore, and I wasn't really convinced very much. That's why I drifted into data-driven machine translation.
Right. Yeah, that's very, very clear and quite illustrative. I would like to ask you sort of the opposite question now, Michael. So which aspects of actual human translation have been factored in when designing current machine translation tools, software, platforms, and environments?
Yeah, I would think none. So what psycholinguists do, or psychologists, and what engineers do to produce machine translation, it's different worlds. So, well, there was a kind of an identity and overlap very much with this computational theory of mind that I just tried to explain. So when you write this rule in a machine translation system, you would have the feeling you captured something about the mind. But this idea was no more valid, say, or it was no more interesting as soon as machine translation became a more commercialized system, as soon as the systems actually worked. So efficiency became a much stronger interest. So the system should work, and it should work fast. And then how the mind works became completely uninteresting for machine translation developers. So in the development of the technology, this idea has disappeared. There is now kind of an interaction between translators and the technology. And this, we can see this on different levels. So we have a machine translation post-editing, where the MT system produces a text and the editor or translator post-edits this, amends the errors. And more interesting, actually, I think, is interactive machine translation, where the machine and the human work very tightly together. So a human post-editor would change something in the text, and this changes would immediately go back to the translation engine and there ameliorate the underlying models so that the same errors would not be anymore produced in future suggestions of the system and so on. So we have a very tight integration of human and machine, which is a human-computer interaction, which I think is very interesting and changes very much the practices of translators.
I would like to go back to something you said just a few seconds before. You sort of foregrounded this more pragmatic approach, where the goal of machine translation is no longer to emulate or try to capture significant properties of the human translating mind, but rather to aim for efficiency and to deliver the type of translation products that users, industries require. Now, I would like to present you with a hypothetical scenario. Imagine you have a very robust machine translation platform, and on the other hand, you have a highly skilled professional human translator. For which types of job, of work, of text would you prefer one, and for which ones would you prefer the other?
There's a couple of parameters. So the one question is, what for do you need this text? So is it a company that wants to present themselves, or is it a user who wants to get some information, rough overview of what happens in this other text and so on? So we can have machine translation, of course, tweaked towards a task, and then achieve a task, a type of a text, and then have very high quality. And this exists already for very many years. So we have a weather report, translations of weather reports, for instance. Weather reports are a very restricted domain, right? So you have a couple of places, you have a couple of weather conditions, and they don't change so much. They are very repetitive and very restricted types of sentences and so on. So for those kinds of very restricted repetitive texts, machine translation works very well. So you can have perfect translation. And this you could already have for many years. Since the 80s, machine translations systems exist. They produce perfect texts for very restricted domains. But now, as soon as the text becomes a little bit less predictable, more open terminology and so on, it becomes increasingly so much more complicated that it's difficult to tackle. Now we have, of course, Google Translate, and everybody knows, I guess, Google Translate, you paste in a text, any text, and it produces some output, increasingly very good, I think. No? So you can mostly understand what happens there. So, so for information, for gathering information, Google Translate works very well. But then we also have kinds of text that need to be considered very carefully. For instance, laws. In the EU, you have so many languages, and these laws needs to be implemented in the different languages, and every word counts there. If a word is ambiguous or not very clear, that may have very severe implications in laws. So laws is something certainly where one would need human translators. Also, if a company wants to present themselves and want to use very brushed up language that addresses a certain segment in the community, so we would need human translators. So there's different types of texts that are suited or less suited for machine translation. There are different types of texts that play a role. And to answer your question, it depends very much on those parameters.
That's a very reassuring answer, I think, and a level one, I should add, in the sense that it deviates from these extreme positions one sometimes finds when discussing these matters. Sometimes you find people who are exceedingly technophile and some others who are exceedingly technophobic in nature, right? And I think that this sort of more leveled and goal-driven conception you bring to the table, Michael, is quite needed at this time. And I'd like to focus a little bit on human translation proper. One of the important developments for the study of human translation has been the emergence of the CRIT, Translation Process Research Database. And you've been involved in this project. Could you tell us a little bit about what this is all about, the origins of this project, and what it offers?
Yeah. So the CRIT database started around 2010 within a project called I2IT that was at Copenhagen Business School. And I was invited to join this project. And so the idea was, I2IT, the idea was to use Translog, which is a program, a research program where translators type in translations. So it has an editor with source text. Translators would see the source text, they type in a translation, and Translog would log the keystrokes in time so that one can look at how the text emerges in time, where people or translators write fluent, where they get stuck, and so on. So this could be traced very, very nicely with Translog. And this was a program that Arndt Lykke Jacobsen developed in 95 with his son. And in 2005, there was this I2IT project, and the idea was to connect an eye tracker to this program. That means with an eye tracker, one could see where on the screen a translator is looking. And then with the key logs, with the keystrokes, one would see what they are producing. So there is an input, a translator scans or reads a piece of source text, types out a translation, and there are a large number of measures that one can then calculate from there. For instance, the I-key span, which the I-key span would be the lag of time between looking at the source word and typing the translation. And those measures would be then interesting to assess how difficult a translation is and so on. So this was a project, I2IT, in 2010 or something. And there were a number of these kinds of data gathered by different researchers, and they were on their local computers or somewhere scattered around. And then I thought, wow, let's put all this into one database to make a consistent format so that others can look into these data and compare their own data with the legacy data from others and have a better kind of statistical values and see how things are different and so on. And that was the idea for this translation process database. So in the meantime, we generated a large number of tools, not only to gather this data in a format, but also to extract features from this data, process and product features. Then by now we have, it is now at in Kent State University on a server, the database. Now we have something like 5,000 sessions, several hundred hours of translator activity data, most of them with gaze, or much of them with gaze data and keystrokes. And it can be downloaded by anyone. It's freely available. We have a browser interface to download the stuff. We have where researchers can upload data, produce their own data, upload, download, compared with other sessions and so on. We have licenses. So if somebody wants to get a license, they can, everybody can download the data for free, but if they want to upload the data and use our toolkits and so on, there are licenses available. They can be used with R and Jupyter scripts on the server directly.
That's a fantastic tool, a great contribution to the field, and it has been used and exploited in many different ways. I wonder, what would you say is the main thing that we have learned about human translation through the use of this database?
Yeah, so we so in this past 10 years, there's a large number of studies that have been conducted with this data, and several PhD theses and so on. So there's lots of documentation and different kinds of research has been done. Basically, the idea is that this database integrates process and product data. Yeah, so the product data is the text, the source text and the target text. So that is the outcome, the input and the outcome of the translation. And this has properties. So we have segments, we have words, we can look into word frequency, part of speech text, how metaphoric are the texts and how are these metaphors presented in the target and so on. So we have the textual data, but then also we have the process data, means how these translations were produced, came into being in time, right? So how many keystrokes were needed to produce a word, how many deletions are there revisions for the keystrokes, for the gaze data, where do translators look on the screen, where do they get stuck, from where do they gather data, so how much ahead in the text do they need to read, or do they go back, do they reread stuff and so on. We have all this information, product and process data, and this is integrated. So this is one thing in this database. And the other thing is, what I think is interesting is look into the variation. Means that if you have a text and a couple of translators, obviously they will all produce different translations, or at least partially different translations. In parts, these translations will be identical, or in part it will be different. So we can assess this variation on the product level, so in the text, what is the variation in the produced words, but also what is the variation in the process. And we can see that in some parts, some stretches of text, there's much variation. Almost every translator produces a different output or has a different behavior, they get stuck and so on. And in other parts, they all agree. They do the same thing and so they produce the same words. So we have this variation in the process and in the product. And it becomes then interesting to see what are the parameters. Why do we see this and what conditions those variations? Do novices produce more variation than experts, for instance? So what is the impact of expertise? What is the impact, what linguistic features, which stretches of words trigger those variations? Is it more due to nouns, to verbs, to adjectives, and so on? So these are the underlying questions there. And then we can see what are the limits of the variations. So obviously there are limits somehow in the variation. We can look into how attention is distributed over the text. Where do translators look? Do they look more into the parts of text that they already produced or in the source text? We can compare this with machine translation. Obviously, different machine translations also produce different texts. There is also a variation in the MT output. And how does this variation compare with human translation? Right? So we can look into those large number of different questions and draw conclusions about the black box or what happens in the mind.
And to conclude, Michael, you are very prolific in your research, and you've been pursuing different research questions. May I ask you about the outstanding research question you're after these days, and if you could briefly tell us what that's all about and what you expect to find in that connection.
Yeah, so we have mostly used Translog for data acquisition, which is a research program which works for those kinds of things. But now we are implementing an interface to Trados. And Trados is a workbench that I think most translators know. It's what most translators perhaps have worked with. It's a professional working environment. And Trados has also a key logging device, which is called Qualitivity. And so if this is started Qualitivity, it produces a key logging output just like Translog. And we have an interface that transfers, that maps this output into Translog, into the translation process research database, so that it can be compared with legacy data there. So this is a project almost finished. And then we add also an eye tracker to this so that we can see where on the screen professional translators work in Trados. Which segments do they look at? What do they produce? So that we have the same setup now with a professional workbench, Trados. So I think this is very promising because it makes this whole research a little bit economical or ecologically more valid. So this is on the technological side. Then we have, of course, since long, the idea that there is automatism. So translators produce translations automatized, so means they have some kinds of patterns, and then there are revision, monitoring interventions. And we are also looking into how this is materialized. What does it mean? How can we trace this in the process data and so on? But generally, I think it's very much in line with the research of this TREC initiative, so translation research, empiricism, and cognition, which says that there is a rigorous investigation in human translation and process research, and TREC wants to make available the data and the insights. So CRIT and our work is very much in line with the very core issues of this TREC.
It certainly is, and we cannot wait to learn about the findings from this exciting research project you just described, Michael. And I would like to thank you for your time, for your generosity, for sharing all your knowledge and experience with us today in Minds Between Languages. Thank you very much for being with us today.
Thank you for inviting me.